Alright, so a student brought up an interesting question. So in the expansion of this expression here, the constant term is 168. Find the value of k. So how do we do this? Well, since we have an x to the power of 3 in the denominator here, we can't take the last term because obviously the last term is going to have an x. It's going to have an x in it. So what we're going to do is find out which term in this expansion. There's going to be 8 terms because it's the power of 7. And we got to find out which one has the constant term. Then the power of x has to be 0. So let's find that out. We can rewrite this as x times x to the power of 4 over 2 plus k over x cubed, all to the power of 7, and we can expand the middle. And that just simply gives us x to the power of 5 over 2 plus k over x squared to the power of 7. Now notice that if in the binomial expansion is n choose r, a to the power of n minus r, b to the power of r. So we can do the same with x's. We can say 7 choose r. We find out what r is. X to the power of 7 minus r. Well, rather, we have x to the power of 5, all to the 7 minus r, and then x to the minus 2 to the power of r. And then, well, we first have to figure out the powers. So let's expand that. So we have 7 choose r. We have 35 minus 5r, x to the negative 2r. And so the exponents have to be 0. So we can do this on the side. 35 minus 5r minus 2r equals 0. That's negative 7r. So 35 equals 7r. R is 5. So we can plug this back in. 7 choose 5. X to the power of 5 to the power of 2, because there will be so that's basically the fifth, that will be the sixth term, right? No, that's the sixth term. So then you have x to the negative 2 to the power of 5, and then that's 7 factorial over 5 factorial times 2 factorial, x to the 10. Oh, actually we forgot something. We forgot the negative 2 here, and there should be a k as well. So that's over 4 times k to the power of 5, and then the x to the power of 10 cancel out, and that's equal to 168, right? So we have 7 times 6 times 5 factorial over 5 factorial times 2 factorial times k to the power of 5 over 4. That's 128. And then the 5 factorials cancel. The 2 and the 6 cancel, and we have 21. 21 over 4 times k to the power of 5 equals 168. So then we can times 4 and divide by 21. Since 168 also is divisible by 3, because the sums of these digits add up to a number that's divisible by 3. That's divisible by 3. So we can both divide it by 3. You get 7. And here I get 56. And so that's 8. 8 times 4 is 32. K to the power of 5 is 32. And so k is 2. And that's the answer.